In this video, I'm going to demonstrate for you the Open Automation Software Unidirectional Gateway, which can be used to transfer data through communication diodes. Communication diodes are used to block communications coming in and allow only network communications going one direction. This was commonly used in the nuclear power industry, and in 2005, Open Automation Software developed this feature for one of our utility customers to transfer data from their nuclear reactors out into their utilities outside of the DMZ. It is now commonly used by our manufacturing customers to transfer data from their control systems out into business applications, user interface for web and .NET, archiving data into databases, or even sending data on to other controllers in other facilities. The unidirectional gateway can be set up to transfer data from multiple OAS engines within the DMZ out into multiple other receiving nodes. So it does support a many-to-many broadcast scenario. It's extremely easy to set up, and if you visit the website openautomationsoftware.com and go to our knowledge base, on the left you'll see a networking section, and there you'll see 4 of our networking types: basic networking, live data cloud hosting for hosting your own data. We have network forwarding, but there you'll see the unidirectional network gateway. If we select that topic, I'm going to now show you how to implement the steps to set up the broadcast node and the receiving node to do the network transfer. In my demonstration, the green OAS engine that I have in the center of the screen here, that will be a Raspberry Pi system that has some simulation tags. And then I'm going to pick up one of the other OAS engines on my local system running on Windows to then display the data or even send the data on to Azure IoT, AWS IoT Gateway, whatever you'd like to do with it. To set up a broadcast, we use the OAS configure application, the same configure application we use to set up tags, drivers, data logging. Let's take a look at the tags on the remote system that is going to be doing the broadcasting. This is on a Raspberry Pi running Linux. And so if we click on that IP address, and we can see we have some simulation data. The data can also be coming from any other data source like Modbus, Allen Bradley, AWS IoT Gateway. We can, of course, have calculations, OPC and OPC UA. Originally, when it was designed in 2005, it was used to transfer data from classic OPC DA servers to other third-party OPC DA clients. But now it can go from any of these data sources to any destination that you would like. So if we set this up, what we would do is go to Configure UDP Broadcast. And what we want to do is we want to set up the Raspberry Pi device to do the broadcasting. And it's very simple. We just select to enable UDP broadcast. We set up the server port number that it's going to broadcast from, and the broadcast rate. That is adjustable. The range is going to be anywhere from 100 milliseconds up, depending upon how much data you want to transfer. By default, we're going to send all values from all tags of the local service, or if we uncheck that, we can select which tags we want to define. I'm going to use this option because it gives us a little bit more flexibility. One, it gives us the advantage to limit how much data is actually transferred. Not all of the tags, but maybe just a selected few that I'm interested. Also, it gives us the ability to transfer data from other OAS engines as well. And the third advantage of using this feature is we can select more than just the local tag. So let's just go ahead and select the tags from the system. Now, because I'm using the network feature, it knows to eliminate the IP address in front of the network. That is fantastic for us because what we're going to do is that is going to be now the identifier that we'll use in the second step of receiving the data. So let's pay attention to that. So we have ramp.value. We'll add that one. We'll add a few more. Notice we have a CSV import and export as well, so you can set these up pretty quickly. I did want to demonstrate for you, though, that we could also send more than just the value. That is a new feature here in 2021 where we can now select any of the variables. There's over 600 variables per tag, maybe the timestamp. Maybe we have some features for time on and count. Any of those values can be transferred. Let's jump down to, say, a high alarm status. So if we go to high alarm active, this is a Boolean that will be true anytime that the ramp is in a high alarm condition. One of the other things we can do is we can receive data from other OES engines within the same DMZ to then to broadcast that data out as well. Let's just emulate that as a network feature. Let's take ramp 2 value, and what we'll do is we'll put in front of that the IP address of that other OES engine. In this case, it is its own data, but it can come from other systems as well. So we'll put that in as an identifier. I'm going to copy that one. The next thing we need to do is to define which destination we want to transfer this to. And we can actually broadcast to multiple receiving nodes if you want to. So the IP address of my local Windows system is 192.168.1.5. So that's going to be the destination IP address that I want to transfer to. And I'm going to use the first port number here of 50,001. We'll click OK, and we'll apply those changes. It is now broadcasting these three values at a half a second to the receiving node. We're now ready to set up the receiving node. To do that, we'll go to Configure UDP Receive. We're going to select my local Windows system, and we'll add a port 5001 and 50,001, and then we'll enable the UDP receive feature. Click Apply Changes. That is now set up to receive data from that broadcasting node. Notice we can set up multiple port numbers to receive data from multiple broadcast systems. So not only can OES engines broadcast to multiple receiving nodes can receive data from multiple broadcasting nodes as well. There is this feature here, it's a property called watchdog rate. That is the number of seconds that if the receiving node hasn't received a value from the broadcast node for the specific tag, it will go to bad quality. I'll demonstrate that for you in a moment. So now if we go to configure tags of the local system, I'm going to hit select. And that warning actually brought up something interesting. It prompted me to save it. I probably should save this UDP configuration. I'll just call it test. And when you do that, it's going to prompt you to make that the default when it loads. If you want the UDP configuration to load automatically when the service starts, you would select yes. And that sets that under configure options. The same for our UDP broadcast as well. I didn't save that, but indeed you'd want to save that onto a location on the Raspberry Pi system at some location and set that as the default as well. So back to the tags. If we go to let's add a group. We'll just call it my tags. And then we can add a tag to that group. We'll call it ramp because that's one of the tags that we had coming in. And we're going to set up the data source as UDP client tag. And now I could use the browse to that from the Raspberry Pi, but in the real world, you've got a communication diode that's going to be blocking that communications into this receiving node. So I don't have a communication diode in place, but you will. So what you're going to want to do is you're going to want to know what that identifier was. That matches up with these tag names that we have defined here. Okay. So once I click Apply Changes, we now see that value coming in from that broadcasting node. Let's create another tag. We'll add another tag. I had another one called random. Now, notice the tag name doesn't have to match what I'm broadcasting, so I could call it ABC as the tag name. And then in the, again with the data source being UDP client, this one was called, let's see what we called it, ramp 2 from that network node. So that was still /192. Well, I'm going to cheat in this scenario and actually just browse for that tag if that's okay. There is that full IP address, and when we click apply changes, that is then coming from an example of another remote node from the broadcasting node. Okay, now we see the data rate there is about a half a second. If we go back to the broadcast system on the Raspberry Pi, we can adjust that down to say 1/10 of a second, and then we go back to configure tags, and we can see the update's much faster. It is now at about 100 milliseconds. Okay, and to demonstrate the network connectivity, that let's say we lose network connection from the broadcasting node to the receiving node, we would want to report that as bad quality. So if I come back under here to the UDP broadcast and simply delete that from the list, and now that is no longer going to be broadcasting, and so our receiving node then goes to bad quality in 5 seconds. So for that particular point. Now, of course, our other nodes, other values are continuing to update as they were. This one's only changing at a 1 second rate because that was our simulation rate, but that was defined under the tags of the Raspberry Pi. Now we're ready to use this data in any of the applications. We can log this data, generate alarms, send alarm notifications, visualize the data in a web interface, bring it up in Microsoft Excel, anything that you'd want to do. The data is treated as if it was live data. If we wanted to transfer the value onto another controller, we'd use the data route feature and enable the target. Here we can set it up to maybe push the data to Azure IoT directly or classic OPC. But if we select tag, MQT is another, we could send data to an MQT broker as well. That's pretty cool. Directly, but if we set tag, any tag that's defined as a particular data source, if it's written to that particular tag, it will write it on down. So say Modbus, MQTT, Siemens controllers, Allen Bradley controllers, they would all be able to receive the data that is being written to them from this source tag. And notice within the tags, as always, we have the CSV export and import, so you can set up a lot of these tags very quickly. To see a list of all of the different destinations that you can push to, go back to our knowledge base under openautomationsoftware.com, and under data destinations, you'll see all of the various types that are common. These are not the only destinations that you can get to, but these are the ones that we have easily documented. For example, if you wanted to make a web interface, and if you wanted to just use our web HMI dashboard, you could just visualize that data directly right on the receiving node. Just to conclude our demonstration, what we've demonstrated is transferring data from a Raspberry Pi device onto a Windows system through using one-way communications, and that would be through a communication network diode, also referred to as a data diode. I hope this video has been informative for you, and if you have any questions, reach out to us at openautomationsoftware.com, and under our Contact Us page, you can send us a request there. You can download Open Automation software right there to try it for 30 days for free.